We hear this term all the time, right? The cloud. Your photos are in the cloud, you're streaming movies from the cloud, all your work stuff, it lives in the cloud. But what is it, really? Is it just a fluffy word for the internet? Or is there more to it? Well, today we're going to pull back the curtain and really unpack what cloud computing is, how it works, and honestly, why it's become the engine that powers pretty much our entire digital world.
All right, so here's our game plan. We're going to start with a really simple definition. Then we'll take a quick look at how we even got here. And after that, we'll break down the cloud using the super handy 543 framework. We'll look at where clouds actually live, what you can do with them, and then wrap it all up with what it means for you and me.
So, first things first, what are we actually talking about when we say the cloud? Because while a lot of people use it as just another word for the internet, in the tech world, it has a way more specific meaning.
Okay, at its very core, this is the big idea. Think about it. When you save a document to your computer's desktop, that's local storage. It lives right there on your machine. But the moment you drag that file into, say, Google Drive or Dropbox, you're using cloud computing. The data and the programs you use to access it are all running on these super powerful remote servers somewhere else. And the internet is just the bridge that gets you there. That's what gives you that magical ability to access your stuff anytime, anywhere from any device.
Now, this whole concept, it didn't just appear out of nowhere. Not at all. It's actually the result of decades of slow and steady evolution, with each new idea building on the ones that came before it.
The journey kind of kicks off back in the 90s with something called grid computing. The idea was to link a bunch of different computers together to basically create one giant virtual supercomputer. But the real game changer, the idea that truly set the stage for the cloud, was utility computing. And the concept was revolutionary. What if we could offer computing power just like an electric utility? You don't build your own power plant at home, right? You just plug into the grid and pay for the electricity you use. That exact idea, computing as a metered service, is the direct ancestor of the modern cloud.
So, to really pin down what makes a service a true cloud service, the National Institute of Standards and Technology, or NIST, came up with this super useful model. And the easiest way to remember it is as the 5-4-3 principles. So let's start with the 5 essential characteristics.
These 5 things you see here, this is basically the official checklist. For any service to actually be considered cloud computing, it has to tick all 5 of these boxes. And together, these are what give the cloud its incredible flexibility and power.
Let's break them down real quick. On-demand self-service just means you can get what you need, like a server or some storage, without having to call somebody or file a ticket. Broad network access is simple. You can get to your stuff from your phone, your laptop, your tablet, whatever. Resource pooling is all about efficiency. Providers have these massive data centers, and they serve thousands of customers from a shared pool of hardware. Rapid elasticity is huge. If your website suddenly goes viral, you can add more computing power instantly. And last but not least, measured service brings us right back to that utility model. You only pay for what you actually use.
Okay, so that covers the what. That was the 5 in our 543 model. Next up is the 4. The 4 main ways that cloud infrastructure can actually be deployed. This is all about the where.
So yeah, it's not like there's just one giant single cloud floating out there in the sky. The actual infrastructure can be set up in 4 different ways, and it really all comes down to a few simple questions. Who owns it? Who gets to use it? And where is it located?
The one we're all most familiar with is the public cloud. Think Amazon Web Services, Google Cloud. These are open to literally anyone with a credit card. Then you have a private cloud, which is infrastructure built exclusively for one single company, maybe for extra security or for legal reasons. A community cloud is kind of a twist on that, where a few organizations with similar needs, like a group of research universities, all share the infrastructure and the cost. And finally, a hybrid cloud is exactly what it sounds like. It's a mix of these models, letting a company get the best of both worlds.
And that brings us to the final piece of our 5-4-3 puzzle, the 3. The 3 main service models. This part answers the most important question of all. What can you actually do with the cloud? People often call this the SPI model, which stands for Software, Platform, and Infrastructure. The best way to think about it is like a stack or a pyramid. Each layer builds on the one right below it, and each one gives you a different level of control versus convenience.
Let's start at the very top of the pyramid with Software as a Service, or SaaS. This is the one you already know and use every single day. We're talking about ready-to-use software that's delivered right through your web browser. You don't have to manage anything behind the scenes. You just log in and go. Exactly. Think about Gmail or Dropbox or Office 365. You didn't have to install a mail server or build a file sharing system. The company that provides the service handles all of that messy stuff for you. You just get the finished product. It's the most hands-off and convenient option. Okay, one level down, we find Platform as a Service, or PaaS. This one is built for software developers. It gives them a complete workshop, the operating system, the coding tools, the databases, everything they need to build and run their own apps, but without having to worry about managing the underlying servers or the network. And then all the way at the bottom of the stack, we have Infrastructure as a Service, or IaaS. This is the most fundamental layer. Here, you're basically just renting the raw digital building blocks, the virtual servers, the storage space, the networking. You get the most control this way, but you're also responsible for managing everything from the operating system all the way up. Okay, this diagram right here, it perfectly sums up everything we just talked about. Look all the way to the left, at on-premises. That's the old school way of doing things. You manage every single thing, from the physical servers in a closet to the applications themselves. Now, watch what happens as you move to the right. See how that blue section, the part you manage, gets smaller and smaller, while the orange Cloud Manages section gets bigger? With IaaS, you hand over the hardware. With PaaS, you hand over the platform too. And with SaaS, you hand over almost everything. This is the central deal, the main bargain of the cloud. You trade direct control for convenience.
So, we've defined the cloud, we've looked at its history, we've broken down all the models. But let's bring this all back home. Why does this stuff matter? Why has this way of doing things completely taken over the world?
Well, like anything, it really comes down to a clear set of trade-offs. The benefits are incredible, right? You can access your data from anywhere, you can scale up instantly, and you avoid spending a fortune on hardware up front. But there are downsides. You are 100% reliant on having an internet connection. You're also trusting another company with your data, which brings up all sorts of security questions. And as we saw, you give up a lot of direct control.
And this really leads us to a final pretty important thought. This shift to the cloud has been nothing short of revolutionary. It's what makes possible so many services we now just take for granted. But as we hand over the keys to our digital lives for all that power and convenience, we really have to ask ourselves, what does it mean when the very foundation of our digital world is owned and controlled by just a handful of massive companies? And that's a question with no easy answer, but it's definitely something worth thinking about.